We are going to do the brownie problem today, and hopefully this is going to help you get a better understanding of multiplying, fractions, and mixed numbers. So as we get started, let's just say you have not a clue on how to do this. Make sure you don't change it to a decimal. I want you to try to solve this problem right here. So you may want to pause the video for that. And make sure you have your final answer boxed in, what you think it is, and then we are going to either prove your answer or disprove your answer. Okay, so now we are actually going to solve a related problem, okay? So this says, Shelley baked 4 pans of brownies. She cut 1/2 of one of the pans to leave for her family. The rest were taken to her school for a cakewalk for a carnival. Of the amount she took to school, 3/4 of the brownies had been won by 10 a.m. How many pans of brownies that she brought to school were won by 10 a.m.? Okay, so what we're going to do is we are going to break this into pieces because this can be a lot. So this says Shelley baked 4 pans of brownies. Okay, so I'm going to model this. 1, 2, 3, 4. 4 pans of brownies. Okay, and let's go on and shade it. Okay, a little bit of a thicker shader here. Not going to be perfect, but that's okay. Okay, so we have 4 pans brownies, okay? So she cut 1/2 of one of the pans to leave for her family. So we're going to say this part here, she's leaving for her family. Okay, so this is not going to be taken to the carnival. Okay, so this is just a way. I'm going to do it this way because normally I do shading. Okay, when I say shading, I normally will shade this way and then this way. Okay. For this, I'm going to actually use colors. So if you're doing it this way, though, if you want to, you can, instead of doing the colors, like if you don't have a color, if you have a color, you could go on and do a light yellow, but you want to do a light color. You can also do this if you would like. Okay, but just do it in one direction. Okay. The rest were taken to her school for a cakewalk for a carnival. So here are this is what we're taking to the cakewalk. Of the amount she took to school, this part here, 3/4 of the brownies had been won by 10 a.m. Okay, so 3/4 of these had been won by 10 a.m. So how many pans of the brownies that she brought to school were won? Well, we know how much 3/4, but how much of that, of what we had? So three-fourths of the amount that we brought. Okay. Now, you can also, if you want to, go on and take this all the way over. It does not matter because this part was left at home. So it really doesn't matter. Okay? So 3/4 were won. So that means I need to shade, mess that up, I need to shade 3/4, okay, of each pan because that's what was taken. Okay? So, almost perfect. So hopefully you can tell that represents 3 out of 4. I'm not shading over here because we didn't bring it, okay? This was 1, 1, 2, 3/4 of this pan was 1, 1, 2, 3/4 of this pan was 1, and 3/4 of this pan was 1. So it says how many pans of the brownies that she brought to school were 1 by 10 a.m. Okay? So remember, we started at school with 3.5 pounds, 3.5 pans. 3/4 of those were 1. So I'm going to start moving these pieces around. Okay? So I can figure out how much was 1. So what I'm saying is this piece here is going to fit right there, right? This one here would fit right there. So that would make 1 hole. This piece here, and it doesn't matter which one, this is just the way I'm doing it. This one here could fit right here, right? That one would make 1 hole. Okay. Now, I still have this piece up here, so don't forget that. This one I've taken care of except for this piece. So this one's taken care of. I have 1 hole set. I have 2 whole pans of brownies that were 1. Now, I'm going to come over here, and I see some partial pieces here, okay? So remember, if I have these 2, that would be like 1 whole line. This one and this one together would make 1 whole line, okay? So I have another line. So I have a line here, okay? So I'm going to go on and move. I'm going to get rid of this piece here. And I know this is a little confusing with me crossing out and stuff like that, but hopefully you're going to get it. So this piece here, I messed up mine. This piece here, these 2, I'm going to put it right here. Okay? So right now, I still have 1 whole pan. Remember, because I moved this one over here, this one over here. I have 2 whole pans. I have 2 sections here, and I still have this 1 little section here. So I'm having a hard time because this is good. Not even look at that. But these 2 here, these are not the same size. This little piece here and these pieces are not the same size. Okay? So in order to make them all the same size, the only thing I can think to do is to cut this in half. Okay, now it doesn't affect that this line went right here. It doesn't affect that this line went right there. What it does help me with is that now I have 1, 2, 3, 4, 5 same size pieces. Okay? So I have 5 pieces, and how many pieces, and I could do it here, I could split this. How many pieces make up the whole? Okay, how many pieces make up 1 whole? 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces make up the whole. So, 5 pieces out of 8, and then I have 1, 2 holes. Okay? So we have 2 and 5 eighths. Now, what you might be wondering is, how does this problem relate to the original problem? So I know this is going to look funny for a second, but I'm going to do it anyway. So, remember our original problem was 3 1/2, right? Well here, remember we started with 4 pans of brownies. 1, 2, 3, 4. And, sorry, no, I'm making a circle this time. I left that much for my family. So actually what I took to the carnival was 3 1/2. Okay? Then I'm taking 3/4 of that. That is what this means. When you're multiplying, it's like taking a certain amount of it. And I probably could have done, it might have made more sense to say this. It might not make more sense to say it that way. this is like my brain logically thinks it's 3/4 of 3.5 pans. Okay? Now, if you did not get this answer up here, we're going to talk about why. A lot of you, and it may not be everybody, but a lot of you may have gotten an answer that looks like this. You might have done 1 times 3, 2 times 4, and then the 3, but that's not the answer. The answer is 2 5/8, so this is incorrect. And the reason is, whenever we're multiplying fractions, we actually have to make sure that we're considering the whole number. So if you were multiplying 1 times 3, that's fine, and 2 times 4, that's fine, but you still have to multiply this 3/4 by the 3. Notice you didn't do anything to the 3. Okay? So you have to consider that the 3 has to be a part of the problem. So in order to do that, to make it for sure that we consider it, we usually make it improper. Okay? So let me erase this for a second and glance down at what this says. So it says, look back, and we're going to try this. So let me see. Let's leave this here. We'll do it like this. Whoops. Okay. So if we have 3.5 times 3/4, then what we want to do is make this improper, doing Texas. This is what we have been doing on our practice sheets. 2 times 3, 6, plus 1 is 7 over 2 times 3 over 4. Now normally I'm looking to see if I can find a relationship. We are going to talk about that later, but I can tell you there is no relationship because 7 and 3 are prime, and also 2 is prime. And I have to have a top-bottom relationship or a diagonal relationship. It can't be side to side. We don't say these have a relationship because these are side to side. So 7 times 3 is 21 over 8, and that's improper, right? So I can't leave it that way. So 21 divided by 8. So I know 8 times 2 is 16, 8 times 3 is 24. So 8 times 3 is too big, so we're going to do 8 times 2, 16. 21, take away 16, 16, 17, 18, 19, 20, 21. When I subtract, I get 5 over 8. And that, my friends, was the answer that we got. Now the models, I know, can be confusing, but some people will understand how these pieces fit together, and it will make a little bit more sense to you. Not everybody, but I know the model is more difficult. In my opinion, the model can be more challenging, but it does show you how it works.